right, welcome to the North America Conference, our last session of the day here. Thank you for attending, and we're glad that you're still here. I hope you found the event really fun and informative, and you've enjoyed all the conference speakers. My name's Grace Beeson, and I'm with Guidewire Software, and I'm also a volunteer from the New England chapter of ISACA. I have a couple of quick housekeeping things, which you guys have probably heard about a bunch, but make sure that you've badged in or swiped your badge if you're in the room so that we can make sure that you're getting credit for your CPEs. For the folks that are doing it from the virtual sessions, please make sure that you're staying on for at least 50 minutes so that you can get your credit for your CPEs. At the end of the session, please make sure that you're doing the surveys, and those can be found on the mobile app or the virtual webcast. And then for all of our sessions, if there are slides available, you can download those from the mobile app or the virtual session as well. So with that, I'm excited to welcome William Malik, and he's going to be speaking to us about what we got wrong in the cloud.
Thank you very much. My name's Bill Malik, and I was actually one of the people who worked on COVID version 3. So, and I'll tell you a little bit about the depth of my background. I actually started in IT while I was in college. As an undergraduate, there was this project called Multics. And during my freshman and sophomore years, I worked with some people developing Multics. Back then we called it hacking, which means finding simple, elegant solutions to complex problems. Well, I actually worked on storage management. I did so at IBM with the MVS operating system in the 80s. And I can neither confirm nor deny that the Unix malik command has anything to do with me personally. This presentation is talking about information security risks, but more in a larger context. We're going to look at 8 specific areas where things broke on the way to the cloud. And the problem is we didn't know that they broke because we were so absorbed with all the beautiful things that cloud was going to do for us that we kind of took our eye off the ball. So in the course of this session, I'm hoping that you'll come to see the importance of sustaining organization knowledge, making sure that the way we run our systems, infrastructure and operations, the systems management, whatever generation you are that uses the term, that we preserve that effective practices, and that we adopt our audit and compliance methods to these hybrid environments. And I'm going to pitch for the metadata catastrophe. And this is a slow problem that as auditors you have a particular opportunity substantially help the way your organizations move forward. And I'll talk about that in more detail. There is a copy of the deck on the site, and I also am happy to give a PDF of this material to anybody who wants to get one from me. So, like I said, we're going to start off with very brief 3 points, one on why we went to cloud, and then a couple on some frameworks that can help. Then we're going to get into the 8 areas of failure, and then reside on an up note, we're going to talk about things that we can do to try to fix it. So there was so much nonsense about why go to cloud in the early part of this millennium. Among the claims I heard was that cloud had infinite capacity. I know that's not true because in the morning I looked out the window and I could see the sun. If there were an infinite number of storage devices, you couldn't see the sky, okay? Cloud does not outperform on-prem because you still have to do something to get to the cloud. So there's always the X factor for cloud plus whatever you're doing locally. And cloud is never more secure than you can do internally. If you take whatever practices you've got and move them to the cloud unchanged, your security is by definition worse because you have more edges. You have more moving parts, right? So be aware of the fact that a lot of the early hype about cloud was total nonsense. I should tell you I worked in Gartner for 11 years. I ran the information security service and also the application integration middleware service during that stretch. However, Good reasons for going to cloud: you trade off CapEx for OpEx. You don't have to buy stuff. The speaker across the way talked about if you want to do monitoring your own, you got to buy extra processing, increase your network capacity, more storage. You need tools, you need people how to run the tools, and all that's true. Notice that if you do it in cloud, you're still paying for it. You're paying for it in smaller chunks. You're paying for it out of an operational budget, and you still have to have the same skills. You have to know how to read the data you're getting, even if the physical process of collection is simpler. Acquisition is faster than on-prem, and that led to one of the largest troubles that we had in conventional organizations, which is the fact that you have people inside who don't understand the importance of the 2-year procurement cycle, right? We can't have LAN, we can't have Wi-Fi, because you can't have a terabyte of storage. That's if you go with the IBM mainframe price, that's going to be a $600,000 acquisition. So you say, well, okay, right, we can't go through that, so I'm just going to run down to Fry's and put 2 half-terabyte drives on my MasterCard, and whoop-de-doo, I've got my terabyte, it's online. The only thing is IT doesn't know it's there. That's called shadow IT. It's been a problem for about 45 years. So, there are reasons for going to cloud, but each one of those positive reasons has a negative side effect. So I'm going to give a moment and just talk about process. I love process. When I worked at IBM Poughkeepsie, we implemented an early version of the CMMI. We used to be a pretty much level 2 organization across the board. Whenever anything went wrong, we had an expert in the component. Oh, geez, it's a storage management problem. We got to go talk to Jack Bauer. Oh, gee, it's a aux management problem. You go get Russ. And having that kind of expertise means you're no longer level 1. You're no longer running around fire drills. But getting to level 3, where you can say something's wrong, let's look at the documentation, then you really have a big, big improvement. When I joined IBM, the current release of MVS, the predecessor to ZOS, was 1.3. It had 1.4 defects per 1,000 lines of code, which meant for the 5 megabyte operating system you bought back then, at no extra charge, we gave you 7,000 bugs. Now, that was after we deployed this and went to the next version of MVS, the XA release. The defect per line of code count went from 1.4 per 1,000 to under 1 per million. Okay? That's a 3-order of magnitude improvement in code quality. Using the same people, writing the same language, it was all old code. The only thing we did differently was the way in which we documented our process. For every line of code we shipped, we wrote 3 lines of test cases, and that was part of the build. It didn't go to customers. If you want to talk about DevSecOps, I know for many of you the sec is silent. If you want to talk about an effective DevSecOps environment, ask yourself if the development team is sharing not just the object code, but also the test case decks, so that operations can validate a problem or do integrity checking on a fix. And when you get a problem report from operations back to development for maintenance purposes, do they bring you a model test case with which you can verify that not only is that problem solved, but all problems of that class have been categorically excluded from that system, from that product, forevermore. And if you're not big into the COBIT model, then you can go with the ITIL model. Difference is COBIT's looking at the details of process, ITIL is looking at the comprehensive, what is it that we need to do to run a data center? At a high level of abstraction, they're essentially saying the same thing. Basically, you want to make sure that you know what's going into your data center, what's happening to it, where it goes, and what control points you have along the way. So now let's take a look at cloud migration risks. Here are the 8 problem areas that we get to cloud. I will elaborate on each of them. First one we're going to talk about is skills and organizational challenges. The issue here is when you migrate to cloud, you're saving a lot of money on capital expense. Here's the problem with regard to skills. Your people begin to wonder, am I an expense? If we're replacing the hardware we bought and learned how to use with hardware we rent and pay for on a monthly basis, How long until senior management decides that a full-time employee with benefits and an escalating salary over time, an escalating cost of benefits over time, is that the wisest use of company funds, or should I just go with third party, with outsourcing, with contractors, with part-time? Can I de-skill and still maintain a level of service? We'll talk about Zero Trust and IDM and just one or two charts. We'll talk about the broad problem of InfoSec and so on. So you're building a cloud. What do you need to do on the way there? Well, there are three domains. The first is people who are doing stuff cloud native from the ground up. You've got a new development process. You're exploring serverless. I'm looking at this chart on the far side. These people are looking for the optimal way to deploy technology using new interfaces, new capabilities, blank slate, greenfield. Whoop-de-doo, we're going to do a whole bunch of things. We'll talk a little bit about the challenges with change and release management. It doesn't go away, but it does morph. On the other hand, we're looking at those organizations that are hybrid and are concerned with operational excellence. How good are you doing at managing cloud compared to other organizations of your size, of your level of maturity, in your industry, and so forth? A lot of compliance metrics there, a lot of assurance checklists there. The point is that for the vast majority of organizations, it's not a greenfield. Maybe a new project is, but you're going to be running an existing environment for a very long time. ZOS forever. There are 15,000 mainframes in the world, roughly. That's plus or minus 1,000. And that number's been stable for about 20 years. The difference is that 20 years ago, the mainframe had a couple dozen cores. Now it's got close to 1,000. The aggregate processing capacity has tracked Moore's Law. It's just we don't bang a lot of drums about it on the mainframe side. But they're still there. They're doing a lot of stuff. If you make a reservation, if you call 911, that's around. So, yeah, you do need to keep some of that expertise. So when you do the transition, there are some people you're not going to use in their traditional capacity. You want to find a new way to use them. We want to make sure you don't lose that skill. As you remission people, as you go through the process of downsizing or right-sizing, you want to make sure that whatever you used to do is still being done somehow, somewhere. First way to do that from an audit perspective is run a gap analysis. Ask your senior leaders, how is this done? Who does it? Check their answers, and then go talk to the people in what's left of the IT organization and ask them, who does this? What is being done? And you can use the COBIT 5, you can use the idle process model, you can use your existing architectural diagram if you've gone to the trouble of actually creating one, and say, okay, we know who used to do this, who does it now? Is there a gap? Is there an expectation on management that Fred does that, whereas the people on IT know Fred took a package and left back in 2019? How do you make sure that you preserve morale? Especially now with record low unemployment, people are stealing folks. Now, those of you who've been around a while, and I see a few here, may remember that in the 1970s and 1980s, you never got a promotion in IT. You just took a job at another company and got your promotion and raised that way. And so people with 2 years tenure in systems management development were all over the place. I was in the Boston area. I had friends who were in southern Michigan. You could actually archaeologically discover when people from various organizations went into other organizations because this new utility would show up. Oh, that's Fred. Fred did that at ConAgra, and now he's doing it over at one of the big three auto manufacturers. Well, do we want to have that? Now, if you expect that kind of churn, you can do it. My first programming job was at an insurance company called John Hancock. They trained people from scratch. You didn't even need to have college. If you passed their exam, they put you through 9 weeks and you learned how to code COBOL. After 2 years, 90% of the people they hired left for other organizations. Scary, huh? Well, not if you architect your systems so that everything there can be maintained by somebody with 2 years' experience. And if you were one of the 10% who was deemed to be like, hey, this gal's a hot shot, we got to keep her on board, then you have a promotion, have a party, say, welcome. I mean, unofficially, it was known as you graduated from your apprenticeship. And then you became one of the core group that stayed there for a while. The point is, you can design your organization to continue without risk by accommodating yourself to the realities of the employment market. Do you require 5 years experience to maintain your systems? How do you keep people for 5 years? If not, what are you going to do to make sure that you've got a constant supply of folks who are clever and can keep things up to date and still maintain the simplicity and clarity of the applications so that they can be maintained by their successor 2 years down the road when they're no longer there? Things to think about from an organization and skills perspective. Next, Zero Trust and Identity Management. I'm not going to spend a lot of time on this. I do a presentation on Zero Trust. I've given it for ISACA a year or two ago, given it at RSA. I'm giving Zero Trust and industrial control systems at RSA in a couple of months. So the idea is, don't believe in a perimeter. Just because somebody's there doesn't mean they have access to stuff. It's not trust but verify. It's verify first, then trust. Make sure your networks are rigorously segmented. Look at the behavior of users and equipment. Basically, Zero Trust is an outgrowth of 3 concepts. There was network access control, which is when you joined a network, the system wouldn't just let you in. It would take a look at your machine, would take a look at your credentials. If your credentials were good, it would then see, do you have one of the permitted antivirus packages? Have you run a scan recently? Are you within a reasonable level of currency with your OS updates? And if the answer to any of those was no, you were routed to an anti-room where you could fix that stuff and apply for entrance again. That's NAC. That was a 90s concept. The Jericho Forum was an organization to promote the idea, right? Joshua fought the Battle of Jericho and the walls came tumbling down. Jericho said, let us not believe in a perimeter anymore. Started around 2004. It graduated and its leadership became part of the Cloud Security Alliance. Very, very important organization that's preserving that stuff. Re-verify device and user integrity periodically. And what's the period determined by? It's by your risk-driven controls. There's a baseline. We got to do this. And oh my gosh, that's the teller who can authorize a $1 million plus transaction, $1 million plus transaction. We got to re-verify that every time they go through a transaction. Identity management comes in because it really is about identity-driven security. Really is about who are you, and the more complex issue, and I wish I'd had a chance to hear her talk yesterday in more detail, the lady who spoke about the identity of things. The problem with things is what happens when I use my phone, it has an identity, and then I plug it into my car, so they get my playlist, my email, my calls, and my maps. How do I identify that hybrid thing? People are tough from an identity management perspective. Things are even harder because things can break into pieces, and then they continue elsewhere. Information security, just a reminder that the principle behind information security is that data should not be lost, altered, or inadvertently disclosed. That's basically the CIA approach. So you want to be able to figure out where things went wrong, and the way to figure out if things went wrong is to follow the incident response playbook from the DHS's CISA group. This is essentially a way of unwrapping the Lockheed Martin cyber kill chain and saying, if I can interrupt an attack at any point, I can prevent the bad effects. The earlier I can interrupt it, the less damage I'm going to have to clean up afterwards. There are references behind all of this stuff. I want to cover the rest of this, and I want to talk about the metadata catastrophe, and then we'll talk about remediation on a couple of decks. So as an auditor, you want to be able to verify that your organization has a tested, effective, annually re-verified incident response playbook. You do not want to end up in a world of hurt. I mean, we had a wonderful session yesterday morning from the SolarWinds CISO. And the message there is, prepare, prepare, prepare. Get yourself in order. You do not want your first meeting with the FBI to be when they're in the midst of an investigation with you. Get involved with InfraGard. Reach out to whatever regulatory agency or investigating covers your industry or your group or your geography. Make sure they know. When the Egghead software breach happened, I had Jeff Sheehan speak at a conference when I was with Gartner, and he talked about that. He heard about the breach on his way in. He said to his VP of IT, I need our head of security to be there at the meeting at 7 a.m. on a Sunday. And the head of IT said, we don't have a head of information security. And I said, well, find one and get his or her butt in that chair. I'll be in the office in 45 minutes. Right? You want an ounce of prevention is worth an infinite amount of cure. In the procurement and contract administration space, as an auditor, you want to be able to shine light in the corners. What do you do in terms of harmonization of your policies with your third-party providers? What does that mean? That means if my third-party provider had to fire somebody for inappropriate behavior on Friday, how many hours before I know that their credentials should not be treated as valid? Right? If their policy is we'll let you know at 8 a.m. at the start of regular business, that means they got all weekend to mess with your system. If they say, oh, we'll let you know right away, but the person they contact is the salesperson who's moved to another area, you want to make sure you got a good contact list. What kind of combined investigative capabilities do you have with your third party? If a problem shows up, how do you know that something didn't happen? Now, some organizations, healthcare is particularly good about this, have rigorous, constant audit. I spoke with a fellow who was with Cardinal Health, and he said they had 5 people full-time dealing with audits from suppliers and downstream users at Cardinal Health. And it was just constant. Said we were completely transparent. Anybody with the right credentials from the right organization and the right contacts could come in, and we'd take them through the whole stuff. Notice those caveats at the front. You don't want some, fraud to come in and do that. What kind of access do they really need? Oh, yeah, you can put this machine into your system. We got to have an unblocked firewalled port to the internet so we can apply maintenance. No, not really. When IBM sold a whole bunch of hard disks to the CIA, their answer was, no, not really. You're going to come on site and we're going to verify the stuff. And I said, oh, by the way, when you upgrade, as a service, we'll just take the old gear and give you the new gear. And they said, no, we are going to do our own recycling. And it involved sledgehammers and a blowtorch. You want to make sure that you've got the right retention and removal policies in place for stuff you get from third parties. How do you validate the stuff you get off of GitHub is reliable? How do you know what you've got? This is getting into another area, which is the whole question of software bill of materials, which I'll talk to in a second. The systems management disciplines are still there. They're in a different form. You do not have the ability to instrument the Google Cloud or AWS to see what the performance is like, what the capacity is like. You can sort of say, well, that's their business. But it's kind of your business because you're paying for what's being used, and if a program goes into a loop and starts consuming storage, at what point in time are you going to cut that off? You don't want to have to pay for all that, and saying it was a mistake, oops, they'll say, well, gee, we're really starting to hear that, but you still owe us this. I was speaking with a fellow yesterday who said that they had 40 people living in their house in Baton Rouge after Katrina. He said it was really something. They were doing laundry constantly for folks who were displaced. He said they were swimming along fairly well, getting used to the close quarters, and then he got his electric bill, $1,200 for the first month. Said, well, we got to do something about this. We got to understand what we're actually using and the cost of it. How does your IT strategy flex when you shift to edge? Now, don't want to go down a rat hole on what edge is, but the best way I found to think about it is you want to take a piece of the internet and make it local. It's not going to replace the internet, but remember that an EM wave travels 186 miles in a millisecond. So if you're routing something that's moving fast, like a car on a highway, you're not going to do it with a geostationary satellite, because geostationary is 26,000 miles up there, which means you got a big delay. The lowest satellite that can sustain an orbit is going to be 150 miles up at its nearest point, and it's only going to be at that location for 5 minutes or so, and right there you got 2 seconds to get there and back. So if you're using satellite technology, you've got to say, I need something closer. I'm going to bring a piece of the Google map right here, right into this block, in New Orleans. So I can see what the traffic is really like, not what it was like 5 seconds ago or 2 hours ago or the last time we updated the map. The three flavors of Moore's Law is a fun one. This is just to point out that, yeah, processor speed doubles every 2 years roughly. Memory capacity doubles more like every 12 to 15 months, and network bandwidth doubles more like every 9 months. What that means is a processor will be 1,000 times more powerful after a decade. Your memory will be 10,000 times bigger, and your network capacity will be 100,000 times greater. What does that say? Well, the bottom line is that Watson was right in the 1950s when he said the world will need 5 computers. He just wasn't quite correct on the network infrastructure. There'll be one in each continent, and you'll move vast amounts of data to get to these processing hubs. And what Edge does is it brings the processing closer to you for the purpose of managing latency. And you have to watch out for rogue processes. With the hostilities due to the Russian invasion of Ukraine, Slava Ukraini, we have seen a lot of ransomware activity kind of tone itself down. They've shifted into crypto mining because they don't want to be noticed. They don't want to end up being targeted, but they want to continue their income streams. So folks that used to be ripping off people are now just stealing your cycles in order to make money. Shadow cloud. This is like shadow IT. Shadow cloud is when you sign up for an application and all of a sudden you've got iCloud. You decided to do something with iTunes at your work machine, and the next thing you know, your corporate system has an open port to iCloud. And you didn't know it was there, but it was just part of what happened when you installed that application. Whenever you use a SaaS application, incredibly cheap, easy to get, you're going to end up, in most cases, having data residing in that SaaS application. You need to know where it is. Cloud Access Security Brokers, CASB, can tell you what's going on and where it is, can help you with that. I mentioned in passing Shadow OT. That may be an unfamiliar term. Quick story. Hospital in central New Jersey. They had a unit with 50 people in long-term care, and the nurses walked rounds every night. Not much would happen, but if something had happened, the nurse would be there within 30 minutes to take care of it. And one of the nurses said, I'm taking care of my uncle at home, and we got this really cool thing off the internet. We just put this pad on top of the mattress, and if he shifts position or if detects humidity, wet something, then it sends an alarm to my phone, and I go up and see what's wrong with my uncle. Why don't we do that here? And head of the unit said, sure, why not? So they went out and they bought 50 of these pads, cost about $80 a piece, right? So for a whopping $4,000, they instrumented every bed in the unit. And now the nurses could handle admission and discharge forms, make sure prescriptions are right, and if a beeper went off, then they were on the job. And guess what? Nurses were happier, patients got better quality of care, they were not being lost all the time, and as a result, everybody was happy. They started talking about it. Other units in the hospital. Pretty soon, they had 2,000 of these simple devices, right? $160,000 capital expense spread across 20 or 30 different departments, never reached the level of threshold of what's going on with the IT organization. They didn't know was happening. And then the head of nursing went to the head of IT and said, could you manage this for us? And the head of IT said, what the hell did you do? Not FDA approved. It's using Bluetooth. There's no security on it. There's no authentication on it. So you've got a massive data leak that's self-inflicted. And because, asking for the beds that have all this stuff built in, those beds cost $9,000 a piece, right? So you can make an $18 million capital budget request, which will you put in a hopper along with all the other things the hospital wants to do over the next 2 to 5 years. Or you can go with what works, and people are smart. They will find this simple path to solution, not thinking about what the consequences are from a security perspective. DevSecOps Sorry for the slight here, but agile does not mean scope creep is okay. You still have to know what your target is. The way in which you get there is okay, and if you discover new things on the way, well, sure, you want to go back, but you want it just not to be build your own adventure kit. You want to get there in a reasonable way, and you've got to have bi-directional information flow. Like I said, you want your test cases to be visible to ops so they can help with some problem diagnosis. You want your ops information to be visible to development so as that they make changes in order to incorporate new environments, that the development community is kept up to speed. This talks about the whole change and release management process. Now, during my time at the Hancock, I was a developer for 3 years, then I was an ops for a couple of years, and I was one of the people that was involved in change and release. Some people misunderstood that as being Dr. No. No, it's not Dr. No. The purpose of change and release is to know what it is that we've got. In a continuous development, continuous integration environment, and you have to audit something that happened 5.5 months ago, how do you recreate that environment? How do you go back and say, this data in this format was processed by this application at this change level? How are you able to reconstruct the audit log if things are changing a couple times a day? That doesn't mean they shouldn't change a couple times a day. It just means from an audit perspective, you'd only left in the dust trying to figure out, well, how do we get back there? How do we know what happened? There's a firm based out of the Bahamas, I think, that does online gaming. Here's a handy hint. I'm not stating a moral perspective on online gaming, just pointing out that when a person calls in and claims that the hand they lost, they actually won, well, it turns out the IT organization is motivated to simply pay the claim rather than try to go through the process of investigating if, in fact, that was true. Now, I'm not suggesting a course of action for anybody. I'm not advocating something that might be considered illegal. But just be aware of the fact that you may have to make some really significant trade-offs that could impact your bottom line if you're unable to reconstruct a reasonable facsimile of history. Now comes the most interesting part. Cyber process hazard analysis and the metadata catastrophe. In the chemical engineering discipline, there is a formal process called process hazard analysis, where you put together a model of the plant, and then you go through it with an eye towards what are the pressures, what are the temperatures, what are the flow rates, what are the capacities, what are the thresholds. When we put this plant up, is it going to blow up? Do we have enough sensors to detect if a level is increasing, or do we only have one sensor that tells us we passed a particular threshold? And you do a what-if analysis to try to figure out what might happen if things go wrong. Now, this is kind of like software testing, but it's a little more because now you're talking about industrial control systems. And industrial control systems, it's not confidentiality, integrity, and availability. In industrial control systems, it's about safety and preserving the integrity of the service. What safety means is even if it breaks, you don't want something to go wrong. You don't want to hurt people. You don't want to damage equipment. You don't want to wreck the environment. And continual availability of the underlying service, that's not talking about the IT. That means even if the thing breaks, it should be usable in some sense. My example is, you've been on an escalator, right? You're at a department store on escalator, here on escalator, and it breaks. What happens when an escalator breaks? It comes to a stop and it locks in place. It doesn't go loose and go rolling downhill and dumping everybody at the bottom. It locks in place smoothly. That's not an accident, that's design. And what does it mean? Even though it's broken, even though it's casters up, it's still a staircase. You can still use it. That's the kind of design thinking that goes in industrial control systems. So the mindset between the IT person thinks, well, if you have to reboot, reboot, that's the second option, not the first. Whereas the ICS person says, no, we're not going to reboot. If you have to cool down and then restart a smelter, the restart process will include destroying the building and building it up from scratch. So you want to make sure that when things fail, there is still some stuff that is preserved. So integrating cyber process hazard analysis into your DevSecOps procedure can significantly diminish the likelihood of dangerous problems hitting you. This is the most interesting one. Metadata catastrophe. And this is a terrible name. It just means there are limits to systems. They are all finite, and the limits can be exceeded. A couple of examples. About 2 years ago, I was at the RSA conference, and I spoke about satellites. And it was March, and I said one of the interesting things about satellites is they have a 10-bit counter that counts the weeks since the beginning of time. Now, in a Unix environment, the beginning of time is January 1980. And a 10-bit counter means that you're going to run out after a little less than 20 years. A little less than 1,024, and the weeks roll over. Now, it happened in 99, and the consequences were invisible because we hadn't integrated the GPS time systems into major processes. But my concern at that conference was that it's going to happen again. It's going to happen in April. I believe it was 2019 that it went bad. And I said, this means that we're going to get bad time signals. We're going to reset. And in fact, we did have some. Not as bad as I thought. I was concerned that ports would be in trouble because there are GPS control devices to load and unload ships. Well, that wasn't the big problem. The big problem was with aircraft. 14 planes, the Boeing 767 and 77, were grounded in China because the console told you altitude, airspeed, and today's date was August of 1999. And if you're a pilot and you know that that was like a while ago, you don't want to fly the plane. So they lost airworthiness on about 14 aircraft. The city of New York lost its Wi-Fi, New York City Wi-Fi, for about 2 weeks. They rolled the counter. They couldn't get connectivity. The police in New York were unable to scan license plates. All of the traffic lights that used timing to optimize the flow of traffic, they fell back. Remember, this is ICS now. They fell back to the point where they just did, 30 second, 15 second, 90 seconds. So it was a real change in the effectiveness of the traffic. Well, here's the problem. We've had issues with, it was called garbage collection in Lisp back in 1959, where you run out of stuff. We've had systems where you have to turn them off and turn them back on. We used to have to do that with the mainframe in the 70s. You have to turn it off and turn it back on because it would fail twice a day. Peak load, 10 a.m., 2 p.m. local time. Well, guess what? You have to reboot an aircraft after 51 days today because counters will roll. We've had Cisco routers. We've had HP network devices that faced rollover, and in some cases they were bricked. In other cases, what did they do with the satellites? Well, the newer satellites are 16-bit, so that's fine. But with the older ones, what they did is to send up a signal to change the date of the beginning of time. So we kicked the can down the road for another 10 years. Well, actually 8 years. A little less than 8 years, right? So in 2030, we're going to begin seeing that again. The fact is, we're going to be seeing this problem all over the place, and the big challenge is going to be with 5G, which is going to go live starting next year, and I mean real 5G, not the 4G LTE++ that you see on your phone. Because you're going to have the rapid provisioning and deprovisioning of environments. We know we can provision rapidly. We've been doing it for a while. But when you get full 5G with one device per square meter across a city center, 1 million devices in a square kilometer, and every time you move from one cell to the next, your entire application stack has to be torn down and reinstantiated on the next host as you're driving or walking through the main of a city. We're going to be seeing provisioning and deprovisioning events escalating, and the problem isn't that we can't do it fast. We know we can. The problem is that every one of these systems has a counter. What's the instance number of this thing? How many have we done so far? And there will be a point in time where that counter will roll, and you went from your 2 billionth to your 2 billionth in first in some environment, and the system stops working. Because either you're going to have two instances with the same name, or you're going to have anonymous instances, and at that moment, your systems management capability evaporates. What you can do as auditors is ask, what limits do we have in our code and in our third-party environments, in our SaaS applications, and in our subsidiaries that have limits that we will run into when we begin accelerating this stuff? I've been around a while. I can remember when people said a 24-bit mainframe was perfectly adequate. Then we went up to 31 bits. Oh, that's virtually infinite storage. And then we got to 64 bits. Oh, we'll never use that up. The reality is, folks, we consume storage at the rate of about a bit a year. We are going to get there. We will run out. And you just don't want to be the person who's trying to figure out how to reboot a system when some of your devices have reset themselves or are hard stopped. Now, having said that, this is a problem that will happen to you individually. It's not going to happen to everyone, although, I don't know what the limits are in the major cloud vendors, but they do have them. I hope it's 64 bits. But the big problem with cloud environments is misconfigurations. If you go back over the last 5 years, you will see 3, maybe 4 instances where a cloud vendor goofed and made their stuff available to everybody. All the rest of the breaches of cloud information were the result of somebody setting a parameter erroneously. Now, I'm not throwing a rock at people who build cloud instances because it's damn hard. There are over 500 parameters you've got to get right. If you get one wrong, you're toast. And there are tools that can help with that. The fellow across the way said that they've got a free tool on their system. I'm with Trend Micro. We have a tool that's not a sales pitch. Use something somewhere. I think DISA has one. I think CASA has one. I think NIST is working one. I think there's one in GitHub that will help check the consistency of the parameters and see if they align with a model dev or a model production environment. And again, as an auditor, you could say, do we do this? When we go through our CI/CD cycle, do we actually check that the parameters there? Because remember, when you create a cloud instance, it is perfectly secure. The only person in the world who can get to it is you. And then you ask yourself, think COVID process, think idle process. As it goes from my instance through the process of development, integration, and its full life cycle, who else has the possibility of changing it? I'm not saying you want to use a privileged access management tool all the way, but that's probably one of the things you want to log. Who changed this setting, when, why, and under what circumstances? Misconfigurations. So, what do we do about it? 2 slides on what we can do about it, and they'll get the questions. Clarify your procedure and then automate. Clarify the procedures is the prereq. If you automate a mess, you get an automated mess. Get to CMI level 3, and you don't get there and stay there because you're lucky. You get there and stay there because you insist on staying there despite pressures. I have worked with organizations, both working for vendors, working as a developer, and as an independent consultant, who have gotten to CMI level 3 and then fallen back because they had a crisis. They had a merger. They had something that forced them to say, in the interest of time, we cannot afford to take the time to update the doc. We'll fix it in the next cycle. If you hear that in a meeting, write it down because it should feature as a finding in your next internal audit review. We made this decision. It was tactically smart. It was strategically catastrophic because we now run the risk of decreasing the quality of our environment by 3 orders of magnitude because we don't know what we're doing anymore. And there's only one person who knew why we did it, and she's on retirement. Make those controls in place early. Prepare for identity management and extend it to your industrial control systems. Get a software asset management database in place. Know what's there. Remember when Equifax was hit by Apache Struts, they got the notice. They kicked off an investigation. The then CTO said, tell me where we're using Apache Struts. And they went through their code base and they said, lucky boss, we're not. They were wrong. They were. Caused a big problem. Take a look at what you do with a software bill of materials. Somebody gives you all of that documentation. This was mentioned yesterday morning at that chat. If you get that, how will you use it? How do you integrate that with your existing software asset management database? Make sure your procurement is aligned, including SaaS, including informal buyers. Again, you don't want to be Dr. No. As an auditor, you want to say, what is the level of cooperation between the development community, the non-development community that is buying cloud resources and other applications, and your conventional IT security posture? How much is formally governed IT and how much is outside? I know of organizations where the IT organization itself spends about 50% of what the business spends on IT. Tend to be high-tech engineering firms where there are a lot of smart people who do not have IT in their title. Make sure your tool sets are consolidated. This is going to be familiar. You've heard this for decades. Most organizations use about a third of the capacity they've bought. 2/3 of the code they've installed and are trained on is not being used. Why? Not because anybody's not minding the storage, because since you bought it, the developer has continued to enhance it. So when you have a request for a new set of functionality, it shouldn't say, we need to buy product XYZ from vendor ABC. It should be of the form, we need this additional functionality to support these environments. And that should kick off an investigation. What tools do we already have in-house that we've deployed, that we're trained on, that we know how to maintain, that can meet this requirement? It may be new to you, but some of your vendors already have it in place. Upgrade and consolidate tool sets. Take a look at how you use Secure Access Service Edge. That's basically Zero Trust brought to a cloud-based environment. Pirate Zero Trust Network Architecture. That means segmenting your network and getting away from traditional VPNs, going point to point. I have a VPN on my machine. I only use it when I have to change my password. Every other app requires multi-factor authentication right from my machine to the server at my corporate headquarters. And make sure you architect. Every time you move something, give it a little thought. And farewell. Good luck with it. Here are some references. They're included in the material. Let me bring up this and see what we have in terms of questions. Q&A. Actual definition of shadow IT means IT that was installed without being officially procured. IT says you can't have a wireless LAN. So the boss goes out and buys a wireless LAN for $95 and you're on the air. I had an interesting afternoon war driving with a couple of folks from the New York Electronic Crime Task Force, Secret Service, where we went through Lower Manhattan with a Wi-Fi detection device, and we found servers in Lower Manhattan with names like M&A Access. Maybe you want to hide that SSID. And when we use vendor tools, why do we use vendor tools to identify misconfigurations if AWS already has tools? What are the additional benefits? Well, first of all, if a vendor provides you a tool, use it. Then take a look at what vendors claim additional tools can do. See if what they're offering is worth the price. The biggest one that comes to mind is once upon a time, Microsoft AV was not very good, but it was free, and a lot of people relied on it. Something is better than nothing. So use what you can. Take a look at if your requirements exceed the basic capabilities. Talk with your peers. Talk with organizations here. And talk to your preferred vendors and see what they've got, and if it makes sense, go for it. And again, this whole presentation's on the deck. Thanks. Fill out the survey, and thank you very much for your time and attention.